All right, let's get right into it. We're talking about one of the most common, yet most hazardous jobs on any ship, mooring. Now, it looks pretty straightforward, but the forces at play here are absolutely massive, and just one tiny mistake can lead to disaster. So let's break down what's really going on out there on deck. And yeah, the stakes could not be higher. This warning, you see, it's not just for decoration. We're talking about the risk of serious injury or even worse. The whole operation happens in a pretty tight space, with just a few crew members wrangling forces that can hold back a ship weighing thousands of tons. So you have to ask, what makes it so dangerous? Well, the real danger isn't something you can always see. It's the invisible tension. It's the incredible stored energy just humming inside every single one of those ropes. And that's where we have to start, with the basic physics of what's happening. Just think for a second about what these lines are actually doing. They are the only thing stopping a gigantic vessel from getting tossed around by the wind, the waves, and the current. All of that power from the environment gets funneled right into these ropes, stretching them like a giant, super strong rubber band. This quote right here, it makes that abstract danger terrifyingly real. It talks about MBL, which is the minimum breaking load. So if you've got an 85-ton load on a line that's rated for 90 tons, well, you're pushing it almost to its absolute limit, 94%. Just let that number hang in the air for a moment. That is the razor-thin margin between a secure ship and a sudden violent failure. And when a rope under that much tension breaks, it doesn't just fall to the deck. It releases all that stored energy in an instant. It's a phenomenon called snapback, and the rope whips back faster than the human eye can even track it. So how in the world do you manage these incredible forces? Well, it's not just one rope, obviously. It's a whole system of them, all carefully planned out. Let's take a look at how this system actually works to keep the ship in place. And this diagram lays it all out perfectly. You have headlines up at the bow and stern lines at the, stern. They keep the ship from drifting away from the dock. Then you've got these spring lines, which are crucial for stopping it from surging forward or backward. See, every single line has a very specific job, and they all have to work together to hold the vessel steady. But of course, a system is only as good as the parts it's made of, and the technology behind the ropes themselves has come a long, long way, all in the name of making things stronger and, most importantly, safer for the crew. And that brings us to UHMWPE. This stuff is a total game changer. Yeah, I know, ultra-high molecular weight polyethylene is a mouthful, but here's what you really need to know. Pound for pound, it can be up to 10 times stronger than steel. That is just a massive leap forward in material science. And you can literally see the difference right here. On the left, you've got that sleek, modern UHMWPE rope. And on the right, that's your more traditional nylon. Now, both are effective, sure, but their properties and how they perform under stress are worlds apart. And that has huge implications for safety and just handling them day to day. This table breaks it all down for us. Just look at UMWPE. Very high strength, very light, and low stretch. That's a powerful combination. Now compare that to nylon. It has high stretch, which can be good for absorbing shock, but it's not quite as strong. Polypropylene floats, which is handy, but it has lower strength. And then you've got wire rope. Incredibly strong, yes, but also incredibly heavy and a real pain to handle. You know, let's just talk about wire rope for a second. It's not just that it's heavy. It needs constant lubrication to stop it from rusting from the inside out. And worse, it can develop these things called fish hooks, tiny broken strands of wire that stick out. They're like little razors that can tear right through gloves and cause some nasty injuries. It's a really unforgiving material to work with. But here's the thing. You could have the most advanced space-age rope in the world, and it's still only part of the equation. Because at the end of the day, safety comes down to the people on the deck and the procedures they follow. So the crucial point is this. New technology doesn't eliminate risk. It just changes it. Situational awareness, really knowing what's happening all around you, from the tension on the lines to a change in the weather, that is every bit as important as the breaking strength of the rope in your hands. And here's a perfect example of a hidden danger that demands total awareness. When another ship passes a moored vessel, it creates these powerful hydrodynamic forces in the water. As the bow of the passing ship goes by, it can actually push the moored ship forward. When it's right alongside, it can shove the whole vessel away from the berth. And as the stern passes, it can make the bow sway out. The crew has to see these invisible pushes and pulls coming and react. Which brings us to the absolute bedrock of mooring safety. These rules are non-negotiable. First, keep the deck clear. No trip hazards, period. Second, everyone must know the hand signals. Communication has to be flawless. Third, and this is the big one, you never, ever stand in a rope bight or in the snapback zone. And finally, of course, you always wear the proper protective gear. And that leaves us with a really important question to think about. As our equipment gets stronger and more advanced, does it truly make the operation safer? Or does it create a false sense of security, maybe leading to a little complacency? The technology is an amazing tool, for sure, but real safety, that will always be a mindset.